Section 6.1 Rectangular Coordinate System. Plotting ordered pairs of numbers. By definition, the rectangular coordinate system consists of the following: 4 quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4, an x-axis that runs horizontally on or left to right, and a y-axis that runs vertically or up and down, and an origin or the center. Note, each individual point has one value for x and one value for y, no matter what the sign of those values might be. The rectangular coordinate system. The line that runs left to right is called the x-axis. The line that runs up and down is called the y-axis. On the right-hand side of the x-axis are all the positive values for x. On the left-hand side of the x-axis are all the negative values for the x-axis. On the upper side of the y-axis are called the positive values for y's. And on the lower part of the y-axis is called the negative values for y's. Once again, in the dead center is what we call the origin, which is labeled as 0, 0, 0 for x and 0 for y. The quadrants are quadrant 1, which has positive value for x, positive value for y. Quadrant 2 has negative value for x, positive value for y. Quadrant 3 has negative value for x, negative value for y. And quadrant 4 has positive value for x, negative value for y. And that is the rectangular coordinate system. Here we're going to be doing a couple of examples of plotting points on the rectangular coordinate system, or the graph. Example A. The point is 2, 2. Positive 2 for x, positive 2 for y. So therefore we already know that the point A should be in quadrant 1. So how do we graph this? We start at the origin, which is in the middle, at 0, and we go over to 2 for x. And from there, y tells us to go up directly 2 units straight up from there. And this is where A is. Example B has a negative value for x, positive value for y. Therefore, we already know that that is in quadrant number 2. So we will go over from the origin to negative 3, and it will go up straight up 3 units from there. And this is where B is. C. Negative 4, negative 1. We have a negative value for x and a negative value for y. Therefore, we know this is in quadrant number 3. So we'll start from the origin, and we will count over negative 4 units to the left and go down 1 unit from there. And this is where C is. Example D. 5, negative 5. We have a positive value for x and a negative value for y. So we will start at the origin. We will count over 5 units to the right and 5 units straight down from there. And that is where D is. E. 0, 0. This is the origin, and as we know, the origin is dead center in the middle. And this is where E is. Once again, to reiterate, the quadrants are quadrant 1, positive, positive. Quadrant 2, negative, positive. Quadrant 3, negative, negative. Quadrant 4, positive, negative. Completing ordered pairs of solutions. Well, completing ordered pairs for solutions is doing something we've done in previous chapters, and that's substituting in a given value for a variable in order to evaluate or solve an expression or equation. See the examples on the next slide. Complete the ordered pair using the following equation. Your first equation or first expression is x plus 2y equals 8. Suppose I gave you an incomplete point A, where I've clearly told you that the x of that point is 0, so therefore I'm asking you to tell me what the y is. So we will use this value in this equation to solve for the missing y. That will go as follows. Zero plus 2y is still 2y, so 2y equals 8. Divide both sides by 2. Y equals 4. So the missing part of point A is 4. Suppose I gave you an incomplete point B, where this time I told you the value for y is 3, but you don't know what x is. So just as in example A, we will do the same thing. However, in this instance, we'll plug in 3 for y, and then we'll eventually end up solving for x. That goes as follows. 2 times 3 is 6. So now you have x plus 6 equals 8. Solve for x by subtracting 6 on both sides of the equal sign. Therefore, x equals 2. So the missing half of point B was 2. Suppose I gave you point C, where I've given you that x is negative 4, but you don't know why. So just as in example A and B, we will do the same thing. We will plug in a negative 4 for x. And we will begin to solve for y, so we will add 4 to both sides. 2y equals 12. Divide both sides by 2. Y equals 6. So the missing half of point C was 6. Suppose I gave you an incomplete table where I've given you some values for x and I've given you a value for y. It would be doing the same thing we just completed doing in the previous slide. Here's your equation. We will use the values that are in the chart to find what's missing. So we'll begin by plugging in negative 3 for x in this equation. We will use a little bit of cross reduction because 3 goes into itself one time. So basically what we have now is y equals negative 1 minus 1, which is negative 2. So the missing half for the first ordered pair was negative 2. Next, we will plug in 0 for x in the same equation. Of course, anything times 0 is 0, so therefore we have y equals 0 minus 1. So y equals negative 1. That is the missing half of that point. However, in the last point, you can see that y is 0, so you're looking for the missing x. So we'll plug in 0 for y in the equation. We will apply the LCD method because we want to get rid of the fraction, so therefore we'll multiply everything by 3. We'll perform the operation, and we have 0 equals x minus 3. We will add 3 to both sides. Basically, 3 equals x, or x equals 3. That is the missing part of that last point. And now the table has been complete. Section 6.2, Graphing Linear Equations. Linear equation in two variables, by definition, is an equation that can be written in the form of ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. This form is called standard form. The graph of a linear equation in two variables is a straight line. Graph the linear equation. Here's your equation. Here's your table. that is incomplete. So we will use the values given to find the missing half of those points. First, x is 0. Plug in 0, do the arithmetic. So y equals 0 plus 1. Therefore, y equals 1. Next, x is 1. Y equals 2 times 1 plus 1, which is y equals 2 plus 1. Therefore, y equals 3. And finally, we have x equals 2. So y equals 2 times 2 plus 1. Y equals 4 plus 1. Y equals 5. So the missing half of the third point is 5. We've completed the table. Now we are being asked to graph these points. Where is 0, 1? Start at 0, which is in the middle, and y says to go up 1. There's 0, 1. Where is 1, 3? Start at 1, go up 3. Where is 2, 5? Start at 2, go up 5. There's 2, 5. As you can see, your 3 points form a straight line. If your points do not form a straight line, that means you probably performed some miscalculations. If so, go back and check your math, because again, your points are supposed to form a straight line. Section 6.3, x and y intercepts. By definition, an x-intercept is a point to where a graph crosses the x-axis. A y-intercept is a point to where the graph crosses the y-axis. Finding the x and y intercepts. To find the x-intercept, we let y be 0. And to find the y-intercept, we let x equal 0. Find the x-intercept for the given equation. 2x plus 3y equals 6. Since we're looking for the x-intercept, we will substitute in y for 0 in the equation and perform the arithmetic operation. So 3 times 0 gives you 0. So 2x plus 0 equals 6, and 2x plus 0 is 2x equals 6. Divide both sides by 2. X equals 3. So therefore your x-intercept is 3, 0. Find the y-intercept of the given equation. 2x plus 3y equals 6. To find the y-intercept, this time x will be 0. We will substitute in 0 for x. We'll perform the operations of arithmetic. And 0 times 2 is 0, so 0 plus 3y equals 6. 0 plus 3y is 3y equals 6. And 3 divided by 3 on both sides. And 6 divided by 3, therefore y equals 2. And therefore your y-intercept is 0, 2. 6.4, slope and rate of change. Finding the slope of the line of two given points. The slope of a line is known as the change in graph along the y-axis vertically and the change in the graph along the x-axis horizontally, often known as the change in y divided by the change in x, and sometimes known as rise over run. See the format below and examples on the next slide. Slope is often known by the letter or variable m. The slope of 2 points formula is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, which is equal to the change in y over the change in x, which is equal to rise over run or fall over run. Find the slope of the line of the 2 points, -2, 3, 4, and -1. First thing we need to do first is label the points correctly. So the first point will be labeled as x1, y1. The second point will be labeled as x2 and y2. Here is the formula for the slope of 2 points. And we will therefore proceed by plugging in the points where they belong properly in the formula. So m equals y2. y2 is -1 minus y1, which is 3, all over x2, which is 4, minus x1, which is -2. Here at the bottom, we have a double negative, which is the negative beside the -2, which therefore forces the 2 to become a positive. So what we have now is negative 1 minus 3 over 4 plus 2, which is negative 4 over 6, but that reduces down by 2 to be negative 2/3. Section 6.5, Equations of Lines. Graph y equals 3x minus 2 using an ordered pair table. This is basically similar and exactly what we just finished doing in the previous section. So therefore, we have 3 known x's, which means we need to find the 3 unknown y's. So we will use 0 first. So y equals 3 times 0 minus 2, which is 0 minus 2, which is negative 2. So the missing half of that point was negative 2. X is 1 next, so we have y equals 3 times 1 minus 2, which is 3 minus 2, which is 1. So the missing half of that point was 1. And finally, we have y equals 3 times 2 minus 2, which is 6 minus 2, which is 4. So the missing half of that point was 4. Here is your graph, and we will therefore plot these points accordingly. So 0 is in the middle, origin. We would go down 2 from there, which is right there. Where is 1, 1? We would go over to 1 for x, and up 1 for y, which is right there. And where is 2, 4? We would go over to 2 for x, and directly up 4 from there, which is about there. There's our graph. Once again, notice the 3 points form a straight line. Once again, very, very, very important. If your points do not form a straight line, please go back and check your math. Make sure you did your math correctly. If your points are not in a straight line order, something went wrong somewhere. Go back and check.